Alright, so we're going to continue with some dividing of radicals, looking at division a little bit more closely than what we did before in the last couple sections. So the first thing I want to point out is that when we divide radicals, it's not a straightforward process. And so, if I had something like 2 divided by the square root of 3, this is not something that's easily or straightforward able to be divided. Instead, the goal of this is not necessarily to divide them, but to get rid of the square root from the bottom. Okay, and so that's our main goal in most of these problems, is to eliminate, let me write this up here, eliminate all roots from the bottom of fractions. Okay, that's essentially how we're going to work with division. Now this process is called rationalizing the denominator. Okay, it's called rationalizing the denominator. The reason it's called this is because you're eliminating the root, which is a rational number, which is an irrational number, from the denominator and turning it into a rational number. Okay, so how do you get rid of a root? How do you turn that into just a whole number on the bottom? And the answer to that question is you multiply a root by itself. Okay, so we're going to use some principles of fractions, some things we know about fractions, to do this. Now I know that if I take a root, a radical, and multiply it by itself, anything times itself is itself squared, and the square of a square root is just what's underneath the root. But if I multiply to that bottom, I have to do the same to the top. Okay, because anything divided by itself is 1. You can, sometimes I'll draw this in so you can kind of see it. This is really just a big number 1 right here. Okay, so 2 over root 3 times 1 is still 2 over root 3. It just might look differently. But now I'm looking at the 1 as being root 3 over root 3. And so when I multiply this out, 2 times root 3 is just that, 2 root 3. But on the bottom, root 3 times root 3 is root 9, and the square root of 9 is 3. So you just use the 3 from underneath. And that's it. We don't have a root on the bottom. We only have a root on top. And that's the goal of these, is to eliminate the roots from the bottom. Okay. Let's look at another example. If I were to take the square root of 5 divided by the square root of, let's go with 10 here. I can do a similar idea. I can multiply the top and bottom by the square root of 10. Okay, the numerator becomes the square root of 50, and the bottom is just 10. Right, so I get square root of 50 times, or divided by 10. However, the square root of 50 can be simplified. Remember, 50 is 25 times 2. So let me take this off to the side here for a moment. 50 is really 25 times 2. And the square root of 25 is 5, and the square root of 2 is just that, the square root of 2. So on top, this root simplifies to 5 times the square root of 2, and on the bottom we have a 10. Now if I cancel, I've got a 5 and a 10 both outside of a root, so they can actually be reduced. Divide this by 5, you get a 1. Divide this by 5, you get a 2. And the final answer then would be the square root of 2 over 2. Okay, so that would be the simplified form. Okay, now some of these examples are going to involve some variables, and so you might have something like, I don't know, how about 9 over the square root of 3y. Alright, so here I've got a variable involved. Same idea, multiply, let's change color up. Let's multiply the top and bottom both by that root. 9 times root 3y is 9 root 3y. And on the bottom, I have the square root of, well, I don't need to write all that. I just have 3y, right? A root times a root is just the stuff underneath. The 9 and the 3 are both outside of the radical, so I can reduce those. Divide that by 3, I get 3. Divide that by 3, I get 1. And so my final answer should be 3 root 3y, 3 root 3y, all over just a y. Right? Cool. Now let's take a look at one more type of problem that you'll see, and it involves two terms on the bottom. So if you had something like 5 over 3 plus the square root of 2. Now here I cannot just multiply by the root of 2 like we were before if I just multiplied by that root, because here if I multiply by root 2 on the bottom, it distributes to both terms. It will eliminate this one, but it will add a root to this term, and so I don't end up eliminating it. But remember, in the last video, right at the end of the last video, we did a problem where we multiplied by a conjugate and it eliminated the radical. Okay, if you'll remember, I'll slide that example in here. It was right here. I took a conjugate, multiplied them together, and I ended up with a number that did not have a radical in it. Okay, it was an integer. And so we'll try that again in this problem. So we're going to multiply by the conjugate of the denominator, which would be 3 minus root 2. But if I do that to the bottom, I also have to do that to the top. Then when I multiply on top, I'm going to actually keep the numerator factored. There's a reason I'm going to do that. I'll show you shortly. On the bottom, I'm going to actually distribute. So 3 times 3 is 9. 3 times negative root 2 is negative 3 root 2. Then root 2 times 3 is plus 3 root 2. And then root 2 times root 2 is a 2 with a minus under. So that is a negative 2. Then when I simplify, the two terms in the middle are like terms with opposite signs, so they add up to 0. And on top I have 5 times 3 minus root 2. On the bottom, 9 minus 2 is 7. Now the reason that I left the numerator factored is because it is sometimes the case that you can cancel right here. If I had like a 5 over 10, I'd be able to reduce those down. I don't in this case, and so I'm going to need to leave those. Okay, but it is sometimes the case that you can cancel here. Now I don't know what my math lab is going to prefer, but it may want you to distribute the 5 on top and call that 15 minus 5 root 2 all over 7. You'll have to read the instructions very carefully to these problems, again, to see, on my math lab which one it will take. I personally would take either of these on a test. Okay. All right, let's look at maybe one more of these examples. Let's throw something in that has some variables in it. Let's go with the square root of x plus the square root of 2 over let's do the square root of x plus 3 on the bottom. Alright, so here again, if you have two terms on the bottom, you have to use a conjugate to eliminate the root. Okay, so I'm going to use the square root of x minus 3 on both the top and the bottom. Okay, it has to be the conjugate of the bottom. Then I'm going to distribute. Now on top, I really could keep these separate at first, but because there's all these terms here, it's not the same as the last example where I just had a constant that I might be able to cancel off. Here we're not going to be able to cancel these off. It's just, I can tell it's not going to work out at the end. So if you've got more than one term on top, you can just distribute these out. So root of x times root of x is x. Root of x times negative 3 is negative 3 root x. Then the two roots together here make a root of 2x. And then this is a minus 3 root 2. A lot of stuff to keep track of here. Then on the bottom, I get root x times root x is x. I get a minus 3 root x and a plus 3 root x. Those, of course, will add up to 0. And then you get the 3 times the negative 3 is a minus 9. The numerator, nothing simplifies. Everything is unlike terms. And so we get x minus 3 root x plus root of 2x minus 3 root 2 all over, we get x and a minus 9. Okay? Alright, I think that does it for multiplying and dividing radicals.